Good day, and thank you for joining us today. In this session, we'll explore how the AboutFlow platform transforms everyday business processes into streamlined, automated workflows. Our focus is on reducing the IT backlog, empowering business users through low-code, no-code modeling, and embedding compliance and governance directly into the way organizations operate. The platform is a low-code, no-code solution that bridges compliance and agility. It empowers business teams to design and deploy workflows, automate processes, and capture records without waiting on IT. With built-in governance, ISO 15489 compliance, and alignment to King 4 principles, it ensures that organizations meet both international standards for records management and local governance expectations for accountability and transparency. The ISO 15489 global standard provides the framework for records management, ensuring that every record is captured, preserved, and auditable across its lifecycle. King 4 emphasizes ethical leadership, stakeholder inclusivity, and integrated reporting. By embedding these principles, the platform supports larger organizations with multiple shareholders in meeting governance obligations and demonstrating accountability. Seamless ERP integration reduces backlogs, while governance frameworks ensure decisions are traceable, compliant, and aligned with shareholder expectations. In short, Collaborator transforms complexity into clarity, helping organizations deliver faster, stay compliant with ISO 15489 and King 4, and remain agile in a digital-first world. Our project approach is structured, transparent, and designed to ensure both compliance and agility. Let's walk through the key stages. We begin by defining SOPs. These provide the foundation, clear, consistent instructions that align with organizational structures. Next, we design the records framework. This ensures that every process is captured, traceable, and audit-ready. With SOPs and records in place, we move to workflow design. Here, we translate processes into automated sequences that users can interact with daily. Supporting workflow design are three parallel activities: modeling to refine processes, reporting to provide visibility, and integration to connect with ERP systems and other platforms. We then showcase a demo allowing stakeholders to see the solution in action, validate assumptions, and provide feedback before full rollout. Comprehensive documentation and training manuals are prepared, ensuring that users have clear guidance and support. Finally, we move into implementation. This includes training sessions and ongoing support to ensure adoption, sustainability, and continuous improvement. This structured approach ensures that every project is not only delivered successfully, but also remains compliant, scalable, and user-friendly. The platform is built on a modular architecture that balances functionality, integration, and compliance. Let's walk through the components. At the top, we have a range of web part applications that consist of data viewers, workspace search tools, advanced queries, inbox that shows assigned tasks, an inbox that shows tasks placed in a pool, SSRS reports, etc. These are the user-facing features that allow users to interact with the platform in practical, everyday ways. At the center sits workflow. This is the engine that drives automation, orchestrates tasks, and ensures processes flow seamlessly across the organization. Surrounding the workflow are data contribute functionality. This functionality allows an external environment to contribute data into the platform. Some of the most popular contributors are web services. The platform caters for both SOAP and REST web services. The functionality include creating records, this includes documents, and trigger workflow instances. These connectors ensure the platform doesn't operate in isolation but fits into the broader IT landscape. At the foundation of the platform is records management, including file plans for incoming and outgoing correspondence, mostly emails in today's world. As part of the records management system is the record control schedule. The record control schedule consists mainly of the various case files that hold transactions. This foundation ensures that every process and workflow is compliant, auditable, and aligned with King 4 and ISO 15489 standards. Together, these components form a complete ecosystem: user-facing apps at the top, workflow automation at the core, integrations around it, and records management as the foundation. This layered design ensures agility, transparency, and compliance in every solution we deliver. Data modeling is the backbone of any digital solution. It defines how information is structured, connected, and used. On a low-code, no-code platform, this process becomes accessible to both technical and non-technical users. Instead of writing complex code, users work with visual schema builders. This makes it easy to design tables, relationships, and workflows directly on screen. The platform provides ready-made connectors to ERP systems, databases, and APIs. That means your data model doesn't sit in isolation. It integrates seamlessly with existing IT landscapes. Because the environment is low-code, no-code, models can be adjusted quickly. Teams can prototype, test, and refine data structures without waiting weeks for IT development cycles. Audit trails, role-based access, and compliance features ensure that data models are not only functional, but also secure and aligned with standards like ISO 15489. Perhaps most importantly, LCNC platforms empower business users. Analysts and process owners can shape the data model themselves, reducing IT backlog and ensuring the solution reflects real business needs. In short, data modeling on a low-code, no-code platform transforms what used to be a highly technical task into a collaborative, agile process bridging business and IT while ensuring compliance and scalability. To show an example on how the platform handles complexity, let's look at this procurement solution. What you see here is a web of interconnected entities, all linked through references and relationships. Just have a quick look at what the model represents. The request for goods and services is where everything begins. A request captures what is needed, who is asking, and the financial coding that ties it back to the general ledger. Requests are linked to commodity standardized codes that classify goods and services. This ensures consistency and makes procurement traceable and auditable. Suppliers respond to requests with quotations. These documents capture pricing, delivery details, and references, forming the basis for competitive procurement. Suppliers is also an integral part of the model. Each supplier is identified with unique details and linked to commodities, agreements, and quotations, ensuring accountability. Once a quotation is accepted, it becomes a purchase order. This formalizes the transaction, linking suppliers, creditors, and line items to the original request. Finally, bills close the loop. They reference purchase orders and requests, ensuring that financial records align with procurement activity and that payments are properly controlled. On the platform, these entities aren't just abstract data points. They're modeled visually, connected seamlessly, and governed by compliance rules. This makes complex procurement processes transparent, auditable, and easy to manage without heavy IT involvement. In real life, the modeler will not just build a solution creating all these entities at once. In this example, the approach would have been to model the suppliers, then commodities, then requests, then quotations, then purchase orders, and then finally bills or supplier invoices, each being accepted by the users in a demonstration before one continued to the next portion of the project. Each entity in our data model, we call them object classes, is more than just a box on a diagram. It's a structured place where data is stored and managed. When you double-click on an object class, you see its full detail, all the attributes that define it. For example, a request for goods and services entity will show attributes like request reference, description, dates, approvers, delivery address, and cost center. These attributes are the building blocks of the object class. They capture the specific pieces of information that make the object class meaningful and usable in business processes. Think of the object class as a container. It holds all related data in one structured place, ensuring consistency and traceability across the system. Because each object class is tied to real-world workflows like requests, suppliers, quotations, or bills, the attributes make the data model directly relevant to operations, compliance, and reporting. On the platform, these attributes can be configured visually. That means business users can adapt object classes to their needs without heavy IT involvement, ensuring agility while maintaining governance. In short, object classes are the anchors of the data model. They store structured and unstructured information, connect to other object classes, and make complex processes transparent, auditable, and easy to manage. Click on the object class view. But how do we see and work with that data? That's where object class views come in. An object class view creates a web part that displays the data stored in the entity. This means users can interact with the information directly through the platform interface. The modeler can create as many views as needed, each with different attributes, filters, and layouts. For example, one view might show requests sorted by priority, while another focuses on supplier quotations. Permissions are built into the system at the record level. That means users only see the records they are authorized to access. Whether it's sensitive financial data or procurement details, visibility is always controlled and secure. This combination of flexible views and integrated permissions ensures that the right people see the right data in the right format at the right time, without relying on IT to constantly reconfigure the system. In short, object class views turn raw data into usable, secure insights. They give business users the power to shape how information is presented, while ensuring compliance and governance are never compromised. What you see here is the result of an object class view created entirely without coding. In our platform, an entity is called an object class, and the view is what makes the data inside that entity visible and usable. The view generates a web part that presents the records in a structured table showing attributes like description, required delivery date, priority, requester, and status. A modeler can create multiple views, each with different attributes, filters, and layouts. This means the same data can be presented in different ways depending on the business need, whether it's procurement tracking, supplier management, or financial reporting. The key point is that this was created without writing a single line of code. Business users can configure and publish these views themselves, reducing IT backlog and ensuring the platform reflects real operational needs. In short, object class views turn raw data into actionable insights, secure, flexible, and business-driven, all without coding. One of the strengths of the platform is that the web parts created here are not locked into a single environment. They can be deployed across different systems, giving organizations flexibility in how they use and present their data. This example shows a deployment within the standard menu system that ships with the platform. Here, the web part displays requests for goods and services in a structured grid view, integrated seamlessly into the broader supply chain management module. Because the platform is modular, the same web part can appear in different contexts: procurement, asset management, project management, without needing to be rebuilt. For the end user, this means they interact with familiar menus and navigation, while still accessing the customized views and workflows created without coding. For organizations, it means solutions scale easily. A view created once can be deployed many times across different systems with permissions and governance intact. In short, deployment is seamless. Web parts created on the platform can be reused across environments, ensuring agility, consistency, and compliance wherever they're needed. The Collaborator platform doesn't just create web parts, it makes them portable. Once an object class view is built, it can be deployed into different environments, including Microsoft Teams. Here, the same web part that displays requests for goods and services is deployed directly inside a Teams channel. This means users don't need to leave their collaboration environment to access procurement data. This method leverages Microsoft Graph authentication. That ensures the same record-level security applies here as it does on the platform itself. Users only see the records they are authorized to access, maintaining compliance and governance. For the end user, it feels natural. Procurement requests appear alongside chats, meetings, and files in Teams. For the organization, it means data is accessible where collaboration already happens. Because permissions and views are integrated, deployment is consistent across environments. The same object class view can be reused in multiple systems without additional coding or configuration. In short, this example shows how Collaborator extends beyond its own interface, bringing structured, secure business data into Microsoft Teams and making it part of everyday collaboration. The Collaborator platform is designed for flexibility. Once an object class view is created, it can be deployed across different environments, not just inside the platform itself, but also into widely used systems like SharePoint Online. Here, the same object class view for requests is deployed directly into a SharePoint Online site. This allows users to register and manage procurement requests within the familiar SharePoint interface. This deployment leverages Azure authentication. That means access is controlled through the organization's existing identity and security framework, ensuring that permissions are enforced consistently across systems. For end users, it feels natural. They log into SharePoint as usual, but now they can interact with collaborators' data and workflows without switching platforms. Once again, because permissions are integrated at the record level, users only see the data they are authorized to access. This ensures compliance and transparency, even when deployed outside the core platform. In short, SharePoint Online becomes another window into collaborator bringing structured, secure business data into the tools organizations already use every day. On the platform, Workflow is the engine that brings processes to life. It takes the rules, procedures, and data structures we've defined and turns them into automated sequences of tasks that users interact with every day. Workflows automate routine steps, routing requests, triggering approvals, sending notifications, and updating records, so that manual effort is reduced and consistency is guaranteed. Each workflow is tied to the entities, or object classes, in the platform. For example, a request for goods and services can trigger a workflow that moves through quotation, purchase order, and billing stages. Tasks are assigned to users based on roles and permissions. The workflow ensures that the right person sees the right task at the right time, with record-level security always enforced. Because the platform is low-code, no-code, workflows can be designed visually and adapted quickly. Business users can model and refine processes without waiting for IT development cycles. Every workflow is audit-ready, with built-in traceability and compliance features. That means organizations can innovate while still meeting governance standards like ISO 15489. In short, workflows on the platform transform static procedures into dynamic, automated processes empowering users, reducing backlog, and ensuring compliance across the organization. When a user opens the detail of an object class, remember, that's what we call an entity. They don't just see the attributes of the data. They also have the option to define a business process. This is where workflows come into play. From the object class detail, the modeler can select the business process option. This opens a list of workflows associated with that object class, such as requests, quotations, or purchase orders. Each workflow represents a predefined sequence of tasks, approvals, notifications, updates that automate how the data in that object class moves through the organization. The modeler can configure multiple workflows for the same object class, tailoring them to different scenarios. For example, one workflow might handle urgent requests, while another manages standard procurement. Once again, I would like to emphasize that permissions are integrated at the record level. That means users only see and act on the workflows they are authorized to access, ensuring compliance and security. This approach turns static data into dynamic processes. It empowers business users to design, adapt, and automate workflows without coding, while IT ensures governance and auditability. In short, defining a business process within an object class connects the data model to real-world operations, making workflows the bridge between information and action. Would you like me to also prepare a shorter, executive-style version of this script, something you can deliver in under a minute, to highlight how workflows transform data into action without going into technical detail? This is an example of a workflow diagram generated on the Collaborator platform. It shows all the tasks in a business process and the sequence in which they occur. Each box represents a task, such as registering a request, reviewing it, requesting quotations, or creating a purchase order. The arrows show the order in which these tasks are performed, making the process easy to follow. Notice that the workflow can branch depending on conditions. For example, if stock items are available, the process moves directly to issuing and collecting stock. If not, it flows into supplier quotations and agreements. The system also allows loopbacks. That means a task can return to an earlier step if needed, for example, if a request needs to be updated or reviewed again. This ensures flexibility and accuracy in real-world scenarios. Each workflow is tied to an object class, so the data and the process are always connected. Requests, suppliers, quotations, and purchase orders all flow seamlessly through the same structure. Because workflows are audit-ready, every step is traceable. That ensures compliance with governance standards while still giving users the agility to adapt processes. In short, workflow diagrams on the Collaborator platform make complex processes transparent, flexible, and easy to manage, turning business rules into automated, auditable sequences of tasks. Here's a clear, professional script you can use to explain task detail modeling and forms on the Collaborator platform. When a user double-clicks on a task in a workflow, for example, register the request for goods and services, the system opens the detail modeling options for that task. This is where the workflow becomes more than just a diagram. It's where the user interface and behavior are defined. Each task has configurable options: who performs it, how long it should take, whether delegation is allowed, and what backend triggers should run. This ensures the task is aligned with both business rules and operational needs. The most commonly used function is the form. The form defines the user interface for the task, what fields are displayed, how data is captured, and how users interact with the process. In other words, it's the bridge between the workflow logic and the end user's experience. Because this is a low-code, no-code environment, forms can be designed visually. Business users can decide which attributes to show, apply filters, and configure layouts without writing a single line of code. Permissions are integrated at the record level, so even within a form, users only see the data they are authorized to access. This ensures compliance and transparency across the workflow. In short, double-clicking a task opens the detail modeling options, and the form function turns that task into a usable interface, making workflows not just automated sequences, but practical, user-friendly processes. On the platform, the user interface for each workflow task is defined through forms. While the system allows full customization, dragging fields onto a canvas to design a screen layout, most screens are generated automatically by the modeler with just a few simple decisions. The modeler decides whether each field should be an entry field, where users capture data, or a display field, where information is shown but not edited. They also determine the order in which fields appear on the form. This simple configuration generates a clean, functional screen without the need for coding. For more advanced requirements, low-code options are available. Modelers can use JavaScript to control field behavior, for example, hiding or showing fields based on conditions, or define actions that trigger updates, notifications, or integrations. This approach means 99% of screens are created quickly and easily, while still allowing flexibility for complex scenarios. Business users get the interfaces they need, and IT teams retain governance and audit control. In short, screen design on the Collaborator platform balances simplicity and power. Most forms are generated with minimal effort, but low-code options are always available when advanced customization is required. While modeling a form on the platform, the user isn't working blindly. The system provides a preview function that shows exactly how the form will look once it's published. As fields are configured, whether they're set as entry or display, ordered in sequence, or enhanced with low-code options, the modeler can preview the form in real time. This allows the modeler to check the layout, confirm that the right fields are visible, and ensure the form is intuitive for end users before it goes live. Because most forms are generated automatically by simply deciding field usage and order, the preview ensures that even quick configurations produce professional, usable screens. If scripts or actions are added, for example, hiding or showing fields based on conditions, the preview shows how those rules will behave, giving confidence that the form will function as intended. In short, the preview feature bridges design and deployment. It gives modelers immediate visibility into how their configuration translates into a user interface, ensuring forms are both functional and user-friendly before they're published. Let me discuss the platform architecture briefly. This diagram illustrates the broader IT ecosystem that supports the platform and its integrations. It shows how applications, client tools, and server infrastructure work together to deliver workflows, reporting, and governance. At the top, we see the applications in use: Collaborator, SharePoint Online, Power BI, Office 365, and biometric authentication. There are also integrations with third-party systems such as financial, HR, and mapping platforms. This is where business users interact with the system. On the client side, users access the system through familiar applications like a browser, PDF viewers, MS Word, etc. This ensures that workflows and data are available directly within the tools employees already use daily. On the server side, SQL Server provides the backbone for data storage, reporting, and analysis. Windows Server hosts services like IIS, Active Directory, and Office 365 integration. Together, these ensure secure authentication, workflow execution, and enterprise-grade scalability. The architecture shows how each layer connects. Applications feed into client tools, which in turn rely on server infrastructure. This creates a seamless flow from user interaction to back-end processing, with governance and compliance embedded throughout. In short, this architecture demonstrates how the platform is not a standalone tool. It's part of a connected ecosystem that integrates applications, client tools, and server infrastructure to deliver secure, scalable, and user-friendly business processes. This diagram illustrates how the platform is deployed in a secure cloud environment, leveraging Microsoft Azure services to ensure both compliance and resilience. Users connect through web browsers, mobile devices, or remote administration. All access routes are secured through Azure Active Directory, which enforces authentication and identity management. Requests pass through multiple protective layers: subnets with network security groups, NSG, a web application firewall, WAF, and a VPN gateway. These ensure that only authorized traffic reaches the application and that threats are blocked before they enter the environment. The core components run on virtual machines: a web application VM for user interaction, an admin workstation VM for management, and an MS SQL VM for data storage. SSL connections secure communication between these components. Azure Backup Center provides automated VM backups, while Redstore ensures off-site SQL backups. This dual approach guarantees data recovery and business continuity in case of failure or disaster. By combining authentication, layered security, controlled access, and resilient backups, the architecture meets governance and compliance requirements while maintaining operational agility. In short, this system architecture demonstrates how security and compliance are embedded into every layer from user access to data storage, ensuring that workflows remain both protected and reliable. Let me introduce a key new development. This is artificial intelligence, and more specifically, the OpenAI platform integrations. Today, we achieved native integration with OpenAI. This means that the platform can now directly leverage OpenAI's capabilities inside workflows, without requiring external connectors or manual setup. Embedded intelligence AI services are now part of the platform's core architecture. Workflows can call OpenAI functions seamlessly, whether for text analysis, decision support, or automation. Assist, automate, decide. The integration enables three key capabilities. Assist. AI can guide users inside forms, suggest values, or provide contextual help. Automate. AI can handle repetitive tasks, such as summarizing requests, classifying commodities, or generating compliance notes. Decide. AI can analyze workflow data and recommend actions, such as flagging anomalies or suggesting the most suitable supplier. Operational transparency. Because the integration is native, outputs are traceable and audit-friendly. AI-generated insights are stored alongside workflow records, ensuring compliance and accountability. Business impact. This isn't about using AI to build solutions faster. It's about embedding AI inside the solutions themselves, making them smarter, adaptive, and continuously improving once deployed. Today, we achieved native integration with OpenAI. This means that the platform can now directly leverage OpenAI's capabilities inside workflows, without requiring external connectors or manual setup. AI services are now part of the platform's core architecture. Workflows can call OpenAI functions seamlessly, whether for text analysis, decision support, or automation. The integration enables three key capabilities. Assist. AI can guide users inside forms, suggest values, or provide contextual help. Automate. AI can handle repetitive tasks, such as summarizing requests, classifying commodities, or generating compliance notes. Decide. AI can analyze workflow data and recommend actions, such as flagging anomalies or suggesting the most suitable supplier. Because the integration is native, outputs are traceable and audit-friendly. AI-generated insights are stored alongside workflow records, ensuring compliance and accountability. This isn't about using AI to build solutions faster. It's about embedding AI inside the solutions themselves, making them smarter, adaptive, and continuously improving once deployed. That brings us to the end of today's session. I'd like to sincerely thank each of you for your time and attention. We've walked through how the Collaborator platform and its AboutFlow version reduces backlog, integrates seamlessly with most ERP systems, and unlocks efficiency through automation, compliance, and AI-driven workflows. Your engagement and interest are what make these discussions valuable, and we appreciate the opportunity to share our vision with you. If you'd like to explore this further, we'd be delighted to arrange a demo and show you how these capabilities can be tailored to your organization. Thank you once again. We look forward to continuing the conversation and helping you unlock the power of efficiency in your own workflows.